carbs, or said more formally, carbohydrates. If you have your pattern matching part 2 activity, you are going to want to take this out or turn to group 4 in there. So it's middle of the way, all the way towards the back. A couple of big picture pieces that I need you to know and be responsible for in there are going to be the function for carbohydrates, and carbohydrates really just give us immediate energy. As we get further into those, they do provide some structure that we will talk about. We'll get more into structure right now. Carbohydrates are also the largest class of macromolecules. They make up almost every single food that you consume, and they are what almost every single food source that you consume breaks down into. And we will get to that when we'll talk about that. Basic elements that you're going to find in there are carbon, hydrogen, and oxygen. And what's really cool about carbohydrates, in my opinion, is that every single thing from the quick, teeny, tiny pieces of the immediate energy to the big, giant structural components that we'll take a peek at are only made of those three things. That's it. It's just those three and these unbelievable, endless combinations of pieces. We do have fancy names for the monomer and the polymer of each of those. The monomer of a carbohydrate is called a monosaccharide. The polymer is called a polysaccharide. And there are a little bit of some differences that are in there in just a second. You can see over in the diagram to the side that the blue up on the top are going to be those. And then also in the orange, there's a reason why this one is kind of in here like this. We'll talk about it. Is the monosaccharide. So there's going to be the smallest building blocks. And then as you move all the way down to the bottom, we sometimes interchange the word polysaccharide with carbohydrate. Technically, they're two different things, but it's a really minute, picky difference between the two of them. And we'll get into that and just you'll understand as we move through things. Because these are the largest group of dietary things that you consume, that's why we tend to mix these two words together, polysaccharide and carbohydrate. And then as you see over on the blue, sugar residues. We'll get to those. So under your monosaccharides, there are really three, and these truly are easiest to talk about in your foods. There are the three monosaccharides are fructose, glucose, and galactose. You can see in this diagram where each of those are found. You might want to hit the pause button, jot all that down. The foods that you find those in, glucose, easiest thing in the world, glucose is sugar. You know it, you've seen it. People who need to have plenty of sugar because they get hypoglycemic, they are consuming a whole bunch of glucose. They're either having too much glucose or they don't have enough glucose. Fructose, you may or may not have also heard about. Fructose is fruits and vegetables. There's a lot of fructose, usually we're talking fruit sugar. So bananas, apples, peaches, anything that is naturally sweet. The sugar that is actually in there, why it is sweet, is because of the fructose molecule, and it is in that particular food source. Last but not least, there is a third type of sugar. It is called galactose. It can seem a little weird. It's kind of sweet, but not necessarily really like sugar sweet, the way we think of like glucose and fructose in there. But honey, yogurt, celery are some food types that are really high in galactose. And if you've ever eaten those, even plain yogurt has a little bit of sweetness, even though it pretty much tastes like sour cream that you're eating. And then honey has a lot of galactose in there. Honey gets all three of those. What you don't know, if you probably don't know, is that galactose is really high. That's the sugar that's really high in honey. So those are your three monosaccharides. Remember, mono means one. So as you take a look at those, they're just one single ring of a carbohydrate, and that is the entire molecule right there. End of story for it. To stick a monosaccharide to another monosaccharide, as in the case that you can see in this diagram, a glucose to a fructose, how we stick them together is through that dehydration reaction. So we're going to pull a water molecule out of there, and you can see that in the red, the OH and then the H get bonded together, and then that would get expelled by the fruit or probably the food source in some way, and then that's going to just naturally disappear. They'll probably cycle and reuse that water in some way. What those two, when they get stuck together, when we get rid of that water molecule and now we have that free open OH spot, and the O on the other side, we stick those together, we call it a glycosidic bond. So the glycosidic bond, or sometimes we say glycosidic linkage, is that's the bond type that is in between two different monosaccharides. Stick enough of those together and we have what we call carbohydrates. And that's why it gets really nitpicky about how you're using the word. So we can have two different types of carbohydrates or two different types of polysaccharides. They can be these, your disaccharides, or these guys, your more traditional carbohydrates or your polysaccharides. We're going to come back to these larger polysaccharide things here in a second. We're just going to start with these three simple disaccharide molecules. So di, the prefix di, right up here. If you don't know, di means two. We're going to use it several times over the course of the year. Please memorize that mono means one, di means two, poly is many. There are only 3 disaccharides in the world. So it's kind of cool. You have 3 monosaccharides. There's only 6 ways to combo those bad boys together in using 2 different pieces. We never stick 2 glucose molecules together and then give it a name. When we stick 2 glucose molecules together, we have a name for that, but none of the other ones go together. So we don't have a fructose molecule, and we also don't have a galactose molecule. But we do have these 3 ones together. Lactose, you probably heard of before. That is your milk sugar. It's the big one that is in there. All dairy products have that guy. Maltose is another one that you have if your parents are consumers of hoppy beverages, malted drinks, beers, and you've ever sampled any of that, or they talk about like the nutty, malty flavor that's in there, that's coming because of a sugar molecule called maltose. And then last but not least, if you are a big baker and you love pulling out that big bag of table sugar, what you're actually pulling out is a bag of sucrose. So sucrose is the kind that we often commonly bake and make fun sweets and treats out of. That's usually the one that people are trying to avoid. They're really trying to avoid that sucrose molecule because it just doesn't do great things in the body. I am a big fan of the sucrose molecule, but not everybody feels that way, and that can commonly be the one that dietarily people try to avoid. More importantly, and what I think is super cool, because again, we're only talking about carbon, hydrogen, and oxygen. Nobody else is getting their big bad boy self in there. We have 2 categories, ogleo and then polysaccharides. So these are these big, long molecules that are really amazing. Starches you've seen before, starchy molecules. They're starchy foods that are what you're probably commonly thinking of, things like potatoes and rice and corn and like these are sweet potatoes, but also regular potatoes. And they just have that really starchy, yummy complex to them. Glycogen is how we store glucose in your body. We're going to talk about more of it later, but it's how you get those stored sources of energy as you really hold on to those. Athletes, you might think a lot about your glycogen stores. That's making sure if you're an endurance athlete, you have enough energy to go the distance. Cellulose is a really cool molecule. It is specific to plants. So if you take a look at this diagram here in the middle, we have broken it down and we've analyzed plant material before. I think the best example of this one is the celery stalk, but you can think of any vegetable that you can think of. Sweet potatoes are another really great example. They have that really stringy consistency to them. That is actually a carbohydrate, and that is a cellulose molecule. So if you didn't know that sweet potatoes are carbs, sweet potatoes are carbs for that reason. The other oligosaccharides that are listed over here are just ones that are from 2 to 10 sugar molecules. They don't really get a special shout out beyond that. Just they're there. They also technically have a name. We don't really care about them. Just really care about the big 3, mono, di, and polysaccharides. So you can see kind of the difference if we lined them up and compared them over here on the very far right, the difference in those bad boys. Just some more polysaccharides because they're just really cool. The difference between starch, glycogen, and cellulose, you can see kind of a bigger picture of those, what they look like. Again, only made out of those carbons, hydrogens, and oxygens just stuck together in a lot of rings over and over and over again. And then they make all of the polysaccharides that are out there in the world. From here, I need you to go take a look at the formative again and go ahead and give that a try for a second time. If you have any questions, you have any problems, please let me know, and I would be happy to help you.